better science, sorting through the BS of life.
Oh, I didn't see you there. So you want to learn about fluids?
Heck yeah, I want to learn about fluids.
Fluids, like water, right?
Time.
Fluids can be a liquid or a gas. Anything that flows. Fluids can be anything that flows, so liquid or air. Anything that flows, like the blood that Dylan's pouring. Even glass, because glass flows down in old houses. You can see that the glass is thicker at the bottom of the window pane. So just anything that flows.
Ah, God, that tastes horrible.
Better science is better than science, 'cause better science is the best.
What makes things float?
Things float because of density. And for density, we use this funny symbol called rho. And rho, because obviously you love density, is equal to mass over volume. And all that tells us is that density is how close the molecules are. So if you think about it like a popcorn kernel, then the popcorn kernel is really dense, and the actual popcorn isn't, because all of the molecules in the popcorn are spread out, and all the molecules in the kernel are all crunched together, or all compact and compressed and
So you're partially right. Density does play into what keeps something floating. But to have something float, you need a force. This is called the buoyant force. If you remember from past chapters, force is equal to mass times acceleration. And if you notice with our density equation, there is also a mass in that. So we're going to solve for mass and plug that in to the buoyant force equation.
Oh, so much time.
So now we have the buoyant force equals rho times volume.
Yeah, you couldn't see it.
The voice you just heard was that of Elena Trudeau. Ignore it at all costs.
Times acceleration. But acceleration in this case will be gravity, since it's going down. And that is what keeps something floating.
No more fighting BS when better science is on your side.
Are you saying things can float in air?
You see, hot air is less dense than cold air. So when I put hot air in this, it floats.
What? I'm still paying attention.
So now about pressure. See, pressure is something that we have that equals force over area. And basically proportional to the area and the force. So if the force stays the same and the area goes up, then the pressure is less. But if the force stays the same and the area goes down, then the pressure is more.
So this topic is connected, but we don't have a good transition for it.
So Bryn was a pretty smart guy. He was a scientist in like 1700s, I don't know, probably earlier than that. And he thought, actually he was right, he didn't just think this, that the total pressure was equal to the initial pressure plus the gauge pressure. And the gauge pressure is just rho gh, so it's just the density of the material multiplied by the acceleration of gravity multiplied by how much of the material there is.
So next we'll be talking about Archimedes' principle.
Wait, I know this one. Wait, I know this one. So Archimedes' principle is a continuation of flow, which is area 1, velocity 1, equals area 2, velocity 2. So if the area decreases, the velocity will increase.
Right. Doesn't energy connect to everything?
Energy is used in Bernoulli's principle when pressure plus potential energy plus kinetic energy stays the same.
Better science.